So we're going to talk today about areas of polygons and circles. We'll start with basic irregular figures and get a little bit into other types of figures, and then we'll carry on with the second or third video after this. Basic areas you already know how to find, right? You know how to find the area of a rectangle, length times width. We'll talk a little bit about triangles and other figures, but what about irregular figures? There's something called a geoboard, and we had just gotten a bunch of them for the department, and now we're all online, so we don't get to play with our geoboards. But geoboards are sort of a neat activity that you can do with students. You just got to watch those rubber bands don't go flying around on a Friday afternoon. But they're plastic boards, and they've got pegs in them, and you put the rubber bands around the pegs, and you can show different areas. So how do you make a triangle with an area of 4? How do you make a rectangle with an area of 3? Can you move those bands in between to create triangles that have the same area but look different from each other? So the area of a rectangle can be used to find the area of a triangle. If you know what the area of a rectangle is, and then you cut a piece of it out, so right here's a rectangle. All right, take your rectangle and draw the diagonal of the rectangle, and you've got a triangle. So if you know that the area of your rectangle is base times height, then you know that the area of that triangle has an area that's half of base times height. And from that rectangle area, all of a sudden now you've also got the area of a triangle. So there is at least one way to figure out the area of this irregular figure, and that is what we call the addition method. The name is not that terribly important. It's just the operation that's important. And it's simply this. If you want to find the area of this region over here, take it and break it up into smaller pieces and add those smaller pieces together. Now, what is the one correct way to figure this out? There is none. You're going to divide this up in whatever way makes sense to you so that you can find the area of this figure. So, I don't know. Tough decisions to make over here. Maybe I'll divide this up in this way. So I'll have one gigantic rectangle over there, and then I got a little triangle over here, and then I've got a big rectangle over here. All right. And then I've got another little triangle over here, and I've got myself a big rectangle over here, a triangle over here. I'm trying to stick with just triangles and rectangles, although obviously this becomes an easier task if you have such things as trapezoids, and then you can put your trapezoids and parallelograms and make it a little bit easier. All right, so let's take all these different pieces and multiply them out. So I got 1, 2, it's 3 units on one side, 3 units on the other side. So region 1 has an area of 3 by 3, which is 9. All right, region 2 is a triangle. That's 1/2 base times height. So the base is 1, the height is 1. 1/2 times 1 times 1 is 1/2. All right, look at piece 3. Piece 3 is 2 units across and 2 units up. So it's a 2 by 2 square. 2 times 2 is 4. That's the area of region 3. All right, region 4 is another triangle that's 1 by 1. So 1/2 times 1 times 1 is a half. Right, 5 is a rectangle that's 1, 2, 3 units across and 1 up. So 3 by 1 is 3. Region 6 is another triangle that's a 1/2 unit, right? 1/2 times 1 times 1. 7 is a 1 square. So 1 times 1 is 1. Region 8 is another triangle that's a half, and that's it. So now if I start adding these together, how many halves do I have? Half plus half is 1. 2 plus 1 is 3, plus 3 is 6, plus 4 is 10, plus 9 is 19. So my area is 19 square units, which I found by taking all those little pieces and adding them together. All right, how about another method? All right, this is how the textbook decided to draw it, a little differently than I did. All right, this method, the rectangle method, says construct a rectangle and then subtract off the pieces. So instead of taking all the little pieces and adding them together, you could be just as effective by taking the whole thing and subtracting off the parts that you don't want. So how big is this whole rectangle? Okay, if I count along the sides, 1, 2, 3, 4 across that side, and 1, 2, 3, 4 across that side. So the whole rectangle is 16. Now I'm going to subtract off the parts that I don't want. So this triangle down here is 2 on that side, 1, 2, 3 on that side. So if I do 1/2 base times height, 1/2 times 3 times 2, oh look, the 2 and the half cancel out, and the area of A is 3. So I'll subtract 3. Okay, B up here is 1 this way and 2 that way. 1/2 times base times height will give me 1/2 times 2 times 1, which is just 1. So that's the area of region B. Right, how about region C? Region C is exactly the same dimensions as B, right? Is 2 across and 1 up. It's a right triangle, so the base and the height are automatically perpendicular to each other, so that's good. So that is now the area of region C. Region D is a 1 by 1 square, so that's an area of 1 also. Region E is the same size as C, is the same size as B, so that's another 1. All right, so 1, 2, 3, 4 plus 3 is 7. 16 minus 7 is 9. That's the area of that irregular region. Okay. Could I have taken this irregular region and divided it up? It depends. It depends, too, how much you know about the different types of figures. Sometimes it's much easier, as I think it is in this case, to take the whole thing, subtract off the parts you don't want. Now, sometimes that takes time, right? Sometimes that's not just an easy one that's done process. Look at this guy over here. All right, if you knew a little bit more about parallelograms and stuff, you might be able to divide this a little bit differently. But how can I find the area of this figure? Well, there's nothing way down the bottom, so maybe it would make sense to draw myself a rectangle of these sides. So what is the size of my rectangle? It's 1, 2, 3, 4 units across and 3 units up. Okay, so I'm going to start with a rectangle that's 12, and I'm going to subtract off a bunch of little pieces. Well, this region over here is 1/2 times 1 times 1, so that region there that I'm subtracting off is a half. All right, what other region should I subtract off? Well, I could probably subtract off this little triangle here, right? That's a 1 by 1, so again, the math that I'm doing in my head is 1/2 times base times height, where I can see that everything here makes right angles. So 1/2 times 1 times 1 is another region that has an area of 1/2. All right, this guy down the bottom is pretty easy. It's a square, 1 by 1, so that area is 1. Now, just be careful about things that are rectangles and things that are triangles and things that are not necessarily triangles. If you were to take this whole piece on the top and try to make yourself one giant triangle out of this piece that goes across here and down here, you can't do that because the hypotenuse of the triangle is going to cut right through the middle of your figure, right? And that's not going to work. So you just have to be careful that when you're doing these 1/2 base times heights, you're actually using the pieces that you want. If you notice what happened down the bottom is I've created a right triangle that's 2 units tall and 3 units across, and the hypotenuse of that triangle is exactly what I want in that figure, right? The hypotenuse is the boundary of that blue figure. So the triangle that's down the bottom there is 2 units tall, 3 units across, right? I'm talking about this triangle in here. 2 units tall, 3 units across. So when I do 1/2 times base times height, 2 times 3 is 6. Half of 6 is 3. So that region over there is 3. And then the piece up at the top, I'm just going to divide up into triangles and rectangles, squares, right? Base of 2, height of 1. Base of 2, height of 1 will give me an area of 1. This guy over here, if you know trapezoids, you can use a formula for a trapezoid. Otherwise, keep it simple, a 1 by 1 square. And then, again, a triangle that has a base of 2 and a height of 1 has an area of 1. So now we got to subtract off all these little pieces, which is not bad. All right, what do we have? If we work systematically, that's 1, 1.5, 2, 3, 4, 5, plus 3 is 8. So 12 minus 8, that thing is 4 square units. All right, did it take a couple of minutes to get there? Yeah. In fact, if you want to find out exactly how long you're watching a video, zip back to when we started the problem, and see exactly how long it took to solve the problem. So this is not something that you would necessarily do in 10 seconds. It's something you would want to draw out all the pieces, but I think it's a lot easier than trying to take all the little pieces and add them together, take the whole figure, subtract off the parts you don't want. All right, converting units of area measure. This one gets a little bit tricky because you've got to remember that you're in a second dimension now. When we were measuring linear things, we wanted to find out how long something was. We were operating in units, inches, meters, kilometers, right? Those are all linear measures. Now you're trying to fill up a space in 2 dimensions. So you want to know how much area is required to fill up that space. So 1 foot is equal to 12 inches. This thing over here on the left is 1 square foot, right? 1 square foot is 1 foot by 1 foot. But if 1 foot is 12 inches on this side, and 1 foot is also 12 inches on that side, if you look at how many square inches it takes to fill up that space, 1 square foot is equal to 12 times 12, which is 144 square inches. In other words, if you want to convert between square feet and square inches, you're not multiplying by 12, you're multiplying by 12 squared, because now you've got 2 dimensions. So just keep that in mind if you're going between square feet and square inches, or if you're going between square yards and square feet, or square meters and square centimeters, things like that. You're multiplying by factors. So you're going to take whatever that factor is and square it, because now you're operating in 2 dimensions. So 1 square foot is 144 square inches. All right, do the same thing for yards. If this thing is 1 yard by 1 yard, then this thing is 1 square yard. You know that 1 yard is equal to 3 feet. So it's 1 yard is 3 feet on that side. It's also 3 feet on that side. So 1 square yard is how many? Count them up. 3 by 3 will give you 9. 1 square yard is 9 square feet. All right, and you can do the conversions from square yards to square inches as well. All right, 1 yard is 36 inches. So you would do 36 times 36 to find out how many square inches are in a square yard. All right, if you want to do some conversions, here's an example. I got a condo that's 968 square feet. No, I didn't sit and measure every one of them. I actually looked it up online on one of these realtor services, and that's what it gave me, 968 square feet. So suppose I would rather measure things in square yards. Suppose it was 1 flat piece and I wanted to put carpeting on it, and rather than square feet, I want to measure things in square yards. So 968 square feet. If I want to go into square yards, there are how many square yards, how many square feet in a square yard? There should be 9, right? 1 square yard is the bigger measure. 1 square yard is equal to 9 square feet. So if I want to go back from square feet to square yards, divide by 9, okay? And whatever 968 divided by 9 is, it's going to be a little bit more than 100. I get 107.56. All right, so it's that many square yards. Doesn't sound as impressive now. How about the last one? How many square inches is this? All right, so how does the conversion go now? If I know square feet, how do I go from square feet to square inches? Well, square feet is the bigger measure. So 1 square foot is going to be 144 square inches, right? 1 foot is 12 inches, so a square foot is 12 squared, or 144 inches. All right, so this time I should take my 968 square feet and multiply it by the 144 square inches. Ooh, this is going to be a big number. This is going to sound more impressive. So 968 times 144, I get 139,392. So it's that many square inches. Well, that sounds a lot bigger than 968 square feet. But you realize now the discrepancy that it sounds much bigger because you're multiplying by factors of 12, not just by 12. All right, how do we do metric conversions? Okay, how do we do square meters and square centimeters? Well, first of all, how many centimeters in a meter? 1 meter has 100 centimeters. So if you drew out something that was a meter on every side, right? This was a meter, and that was a meter. This thing here, we could call 1 square meter. that same distance in centimeters, well, if a meter is equal to 100 centimeters, now you've got a square that's 100 centimeters on that side and 100 centimeters on that side. So I end up with 1, 2, 3, 4 zeros. Okay. And that is in square centimeters. So 1 square meter is 10,000 square centimeters. And if you're not sure how that works, draw out one of these little pictures to help you out. All right, the one after that talks about a square kilometer. So this is a pretty big measure, right? 1 square kilometer is something that's a kilometer on either side. So 6/10 of a mile on one side, 6/10 of a mile on the other side. It's a pretty big plot of land. So 1 square kilometer is something that's a kilometer on either side. And kilometer on this side, kilometer on this side. A kilometer is equal to 1,000 meters, right? A kilometer, kilo means 1,000. So it's 1,000 meters on this side and 1,000 meters on that side. So we're going to end up with 6 zeros after this. 1, 2, 3, 4, 5, 6. So a square kilometer is 1,000,000 square meters. Now, 1,000,000 square meters is how many square centimeters? Well, a meter is 100 centimeters. So we would take the 1,000 meters and multiply it by 100. So we already have 1,000 meters, and we're going to multiply it by 100. So that kilometer is 100,000 centimeters. So it's 100,000 centimeters on this side and 100,000 centimeters on this side. Count up those zeros. 5 on here, 5 on there. You're going to end up with 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put our commas. Every 3 we put a comma. Not there. All right, so we count out 1, 2, 3. There we go. It's that many square centimeters. So what is that? Million, billion, 10 billion square centimeters? That's why it's easier to measure something as a square kilometer rather than 10 billion square centimeters. All right, let's look at one other type of measure, and then we'll move on to areas in a second video. We've talked about a square kilometer. That's a pretty big area. How about acreage? Okay, land measure is generally measured in acres. If you're going to buy acres of land, how big is an acre? Well, an acre is 4,840 square yards. Great. How many square feet is this? So if you had a conversion between square yards and square feet, how would it go? 1 square yard is going to be 9 square feet, right? Feet is a smaller measure, so there's 3 feet in a yard, but there's 3 feet in a yard on either side, right? So there's 3 feet on this side, and there's 3 feet on that side. 3 times 3 is 9. So 9 square feet is the same thing as 1 square yard. So if you want to find out how many square feet are in an acre, take your 4,840 square yards and then multiply it by the conversion. So the conversion is there's 9 square feet for every 1 square yard. Your square yards cancel, and then you just multiply. So you multiply 4,840 times 9, 43,560. So 43,560 square feet in an acre. All right, so my question then is, suppose you had a square piece of land that measured exactly an acre. How long would it be on either side in feet and in yards? So if you have a square and you want to find one side of the square, right? This piece over here, we said was a square, so it's got sides that are the same. So that side squared equals 4,840. Now we're going to have to take the square root of both sides. We're not going to worry about the plus minus because nobody's got negative sides in their plot of land. So on your calculator, you're going to have to find the square root button, wherever that is, and take 4,840 and take the square root of that. All right, so when you take the square root, 4,840, you get 69.57. 69.57 what? yards. That's how long the side of your square is. So if you have a square that's almost 70 yards on one side, 70 yards on the other side, that's the same thing as an acre. And then if you want it in feet, then just multiply that by 3. As a little trivia question at the end, how many acres is in the Raritan Valley campus? Okay, there actually is an answer that's up on the website. So if you go to the PowerPoint and you click that link, I don't want to ruin the surprise for you, but if you got a little guess, what do you think? Do you think it's like 50 acres? Do you think it's 75 acres? Do you think the whole campus is 10,000 acres? What is your concept of an acre? Now, remember, I know we're not on campus right now, but remember there's that big area in front of campus. There's that pond that's up in the front. There's the parking areas. There's the buildings. And then there's that area in the back by the arts building and the football practice areas and baseball fields, and then all the way in the back of the campus as well. So think about that, come up with your best guess, and then click on that little link. You'll see the whole thing with the history, and I'll tell you in those first couple lines how many acres is on the Raritan Valley campus. All right, we'll tackle areas after this.